Okay, going on to our vocabulary check for our Chapter 4 summary. Fill in the blanks. Here we only have 2, 4, 6, 7. I see 8 words up there. Oh, I see one has 2. Ah, okay. Now, again, I haven't looked at the answers. I could have. I'm sure they're somewhere in there. But I'm going to be like a student, and I'm going to see what I can do. In a system of linear equations in two variables, if the graph of the equations are the same, the equations are, I think the word was dependent. There we go, number 1. Dependent equations, if the graphs are the same. Two or more linear equations are called systems of linear equations. A system of equations that has at least one solution, I remember that one, is consistent. No solution is inconsistent. We'll get to that here. Let's see, a what of a system of two equations and two variables is an ordered pair of numbers that is a solution to both. Well, a solution, I guess. Two algebraic methods of solving systems of equations are, this is going to be substitution and addition. Well, actually that's a 5 again, isn't it? It could be in any order, actually. Okay, a system of equations that has no solution, that would be inconsistent. And in a system of linear equations and two variables, if the graph of the equations are different, the equations are independent. All right, so that one was actually a little easier. And it helps practice our vocabulary a little bit. I don't often feature that, but we're doing that. Okay. So a solution is that point of intersection of two lines where there is a common point of coefficients there. Coordinates would be a better word. Yes, let's go on. And again, this is a good review because it shows what's going on. Now, whether we're doing word problems or whatever, this shows we're looking for that point of intersection where we get the coordinates of that particular point. There's your X, there's your Y. And we said that here's the vocabulary again. Having at least one solution was consistent. Different equations, the equations are independent. Here it's the same equation, so there's at least one solution, consistent, and they're the same equations, so the equations are dependent. Here there are no solutions, so it's inconsistent, and the equations are different. They are independent. Okay, and then we studied the system of solving equations by substitution, where we have solved for one letter, then put this other value into the equations. And here's a summary of the steps. Then we did elimination, which can also be called addition. We're modifying equations so that something cancels out and then finding the other letter. And if we ended up with an untrue statement, there was no solution. A true statement, there was an infinite number of solutions, and we write the answer in set builder notation. Now, we didn't do any with 3, but basically, if you had them set up, you're looking for equations where you could cancel out one of the letters. So here, this is equation 1, this is equation 2. Can you see that if you added these first 2 equations together, the y's would cancel out there? Then you'd have an equation with only x and z. And then if you took equation 2 and equation 3, by modifying equation 2 by a -2 each term, then the y's would cancel out there. And that's what they're doing. And now that you have 2 equations with only 2 letters, you then do what we were doing, eliminating the other letter till you just have 1. It's just that it's more tedious to do, and in some classes we used to do those, but we never did it in Math 1103. We would do that in the next course, not in this course. Okay, and then they had some word problems in which you convert into 2 letters, get 2 equations, and then eventually solve it and interpret your results. Okay, we'll keep this short. Good luck on your test. Try to be up to date with your quiz me's, your study plan, your mastery points.